space, and it's a very up and coming software principal, software discipline, and it's as within the US job market, there's a lot of explosion going on around this, and the skills gap is pretty high in the sense that like the recs that are coming up and the skills people are right now getting to know the process, getting to know the AI skills as to where they have to focus on and all is still up and coming. So this is a very good opportunity to get into this market right now. So I'll explain things further. So I'll give it to Naga. Naga, can
Yeah,
you?
Uday, sorry, just recording started just now. You can share your screen again.
Yeah.
Yeah, Naga, go ahead. Thank you.
Yeah, sure, Satish. Thanks, Uday. So, hi everyone. I have about 19 years of experience in IT industry, and I have been working on several uh, frameworks and technologies. Like starting with my career, I have been into Java, and have been into Java stuff for almost 15 years. And I did work on big data technologies, Hadoop and Spark for 4 years. Especially last 2 years, I'm with like financial domain working on implementing some of the AI GenAI frameworks RAGs and Agentic AI implementing to detect their frauds in their transactions and uh, there will be like some risk management things we're trying to identify like if there any risk using like especially using like NLP and RAG techniques. And in terms of the domain, like I have been working on several domains like telecom, government sector. Currently, I'm with banking. My current client is like Wells Fargo. Uh, it has been great opportunity to like teach you guys and collaborate with you. Looking forward to working with you all. Thank you. Yeah, Uday, go ahead.
Yeah, great.
Yeah.
Yeah.
Okay. Satish, can I go ahead and start?
Yeah, you can start.
Okay. So over the past couple of 5-10 years, if you have seen market trends, data science, machine learning has and deep learning have picked up pretty fast. And you see, like between the US job market and the India job market, there are so many open recs, open jobs, but the gap within the market for these skills is pretty high. So the number of opportunities that open up and the folks that are thoroughly skilled in this area, it's there has been a huge gap. So it's always supply demand with these things, with new technologies coming up on a day-to-day basis, trying to learn them, getting them up to speed, and matching the market trends to get into better jobs and on bigger salaries, bigger paychecks, and all. That has been the same trend with machine learning, deep learning, and data science. Between 2015 and 2020, this was the range. But between 2022 through 2025, as of today, NLP Gen AI has picked up and it is moving very fast in the sense that not only companies which are adopting these new technologies, as well as new standard frameworks, new tools, they are coming up on a day-to-day basis. And that kind of brought up together a new software discipline called Agentic AI. And that is being very quickly adopted by companies as well. And on a day-to-day basis, me and Naga, we look at the job trends and all within the US market, and we see a lot of opportunities coming up but there are not enough people to fill those gaps within the market. So as I said before, this is a very good time because these software disciplines are not standardized yet. The tools are coming up, the all the principles and everything are being developed, protocols and everything is being developed, but it hasn't reached a saturation point where everything is standardized yet. So it is a very good time to learn these principles, to learn these technologies, and get into the market. It's not only within the US job market, but the given how the Indian market, Indian startup ecosystem, the enterprise service companies, product companies ecosystem, they are also quickly adopting all these things. And there will be a huge surge of opportunity that is come that has opened up within 2025 and beyond, as we'll see in a few slides. You'll see how much investment is being done in this sector that you can kind of be a part of, and also maximize the opportunity not only from a salary standpoint but from a opportunity standpoint with across multiple companies, because this is not kind of these two disciplines are not kind of restrictive to a single business domain like finance, banking, insurance, or anything. Like these are applicable everywhere. So the adoption is going to be pretty high here.
Hey, Uday,
So
I think, Uday, I'm sorry to disturb you. Few slides totally we have missed out. If you have shown on your screen properly, that was not
so,
shared.
sorry, I didn't quite catch that.
You were giving, while you were giving some context to this, agentic AI tools,
Yeah.
the related slides totally we missed out. Did you show anything on the screen?
No, I haven't gone into the slides yet.
Uh,
Any other
no,
questions?
sorry, Uday, please go ahead.
Yeah. So
Is this
so
program will teach you technical developing also? Like how
yeah.
to
So
apply the
the
agents technically using LangChain and these are the tools using these tools.
yes, the intent is that. As we go forward, I'll give a more broader overview as to what topics we'll cover.
And we will
So
show
that
the
should
course content also, brief course content also. Then you can understand how much technicality will be there.
Yeah, I would request like asking questions at the end so that he will be able
Sure,
to
sure.
cover.
Just please allow us for next 40 minutes. Then we'll spend up half an hour time for the question and answers. We'll show everything. Thank you. Go ahead, Uday.
Thank you. So from a ecosystem perspective, like how everything kind of evolved over the course of the past 10-15 years within the field of machine learning, deep learning, and generative AI, as the problem set kind of is starting to get complicated, the solution that gets applied also changes, and this is how it has evolved over time. With machine learning, the idea is to have a simple predictive analytics kind of problem set that again has a lot of algorithms that are used within the machine learning ecosystem, and but the number of attributes or parameters that are required to make these predictions is also pretty limited, and those fall under, and all these parameters fall under proper structured data that kind of gives the machine learning algorithms the ease with which they can do all this predictive analytics stuff. So there is a structure to what the data is applied to, and the bedrock of this entire ecosystem is data. So if you don't have proper data, a machine learning solution or a deep learning solution or a generative AI solution is kind of it's useless if you don't have proper data to cater to the problem. So with deep learning, you are still looking at the same predictive problems in one group, but the data what you feed to a deep learning model changes. It's unstructured. There is no visible relationships between different attributes within the data. So the challenge becomes how can you make sense of that data? So the problem is now changing. So to handle those kinds of problems where you don't know what the data, like what patterns are in the data, you evolve the model to cater to that particular need. And that's how deep learning comes into the picture. And that with that, it brings a change in the infrastructure, like you require more computing power, more storage compared to a machine learning model to deep learning. And further in, if you have, but both machine learning and deep learning are trying to find patterns in data, and based on those patterns, they're trying to make predictions. Generative AI is a subtopic within deep learning in the sense that you are generating new things. Like there's a concept of a multi-model generative AI in which talks about, can I generate new text? Can I generate a new image or a new video as such? A simple example would be, if I learn the English language, so if I learn 10,000 words, and if I know a structure of a sentence, so whatever I'm talking about, say if I have this slide, if I look at this sentence, it is coming from the limited vocabulary I have. So I learn a sentence structure, I learn some words, and I put together a new sentence so that it makes sense to the person who reads it. So with the training I get from the English words and the English sentences, I try to create a new sentence. Same is with native language, with Telugu, Hindi, any other language. The way you learn is you learn the alphabets, you learn the words, you learn the sentence structure, and from there on, that's how you create your own sentences and speak or write an email. Many use cases you can do using language. So that is a similar pattern you see in generative AI. So within generative AI, there is the concept of training a model and making use of that model to generate new content. So it becomes very powerful. So you see all these, a lot of people who write essays online in blogs and all. They sometimes use these generative AI models to generate essays to generate content about a topic, be it movie reviews or be it anything around research papers and all that stuff. So generative AI becomes powerful in that aspect, and you can and the possibilities are limitless. Generative AI can be used across multiple use cases. A very real life use case which I work with in the fintech area is providing support to financial clients so that they can get information without having to go out of their browser and doing a Google search or something. All the information is in a single place. And that particular chatbot, GenAI chatbot, also goes one step ahead and creates documents and slides and all. So all the slides you see here, these are generated off open. So some of these slides, what you see here, are generated off a GenAI chatbot. that this is a very practical use case you are seeing. And Naga also within his banking domain, he has seen a lot of live use cases around fraud detection and bank transactions. You have to make sure transactions are legitimate. So all these things, the possibilities open up with generative AI. So the one thing what I want to keep into perspective is the problem statement also changes. It evolves. It becomes more complex. As it becomes more complex, you are changing the solution as well. You are changing the method, the way you solve the problem, and the solution as well. So what we call is machine learning, you can have a few parameters. With deep learning, you can have few thousands or few crores of parameters. With generative AI, it's completely different. The latest GPT-5 model has about 1700 crore parameters with which the models are trained. So to translate that into simpler terms, imagine you have the entire data across internet, then you have entire data across all libraries in the world, and you train your model with that. And that's how much your model is smart enough. It can discuss with you any topic, it can teach you any topic, it can uh, generate new content based on existing topics and all. So that is the power of a generative AI model or the concept of generative AI. So moving on, we'll look at how the market is evolving with the generative AI. So here are some stats I wanted to share with you. So generative AI took off when in 2022, OpenAI, they released their first model, GPT-0, and it created a revolution. And from there on, the investments have been flowing into the generative AI area. So this is just only a portion of how much that has been invested within across the world between US, India, and China. This is peanuts. 40 billion is peanuts. But as the market is increasing, it will grow at a rate of 30%, 30 to 40% year over year. And it will hit close to $1 trillion. That's like 1,300, 1,400 crores. So with all this stuff, so why are people investing in this? Because the problem it solves, the complex problems it solves, its potential is unique and limitless. With that, it brings opportunity. Where does agentic AI fit in the picture? So with generative AI, we talked about generating new content based on some pre-trained knowledge, which I would get as a model, which as a model would have with all the huge amount of data available on the internet. You train a model and it's pretty smart, intelligent, and it can generate new content. But where agentic AI falls into the picture is it will give this AI system to perform tasks that as a model it itself can't do. So if you want to say raise alarm or send an email to someone, the AI model in itself can't do that, because the purpose of an AI model is pretty much like a mathematical model which pushes some results out. But if you want to give additional capabilities, such as imagine based on an output, you need to send out an email or maybe send out an SMS. or anything on those lines. How would you add those extra capabilities to a model? One other example would be if based on the output, if I want to run a SQL query, what would I do? So these kinds of additional capabilities, if you see, you can enhance the model to do all these things using agents, workflows, agents. So the concept of agentic AI, it it is pretty much the similar to how you write intelligence in your applications like microservices or full stack applications. Your full stack applications can do REST APIs, they can run SQL queries, they can do another example would be publish into a Kafka topic and do all those things. So your agents will provide a similar set of capabilities to your model, and that's very powerful. So alongside the GenAI market, the agentic space is also growing at a very rapid rate. So look at it this way: all the transfer skills that you have acquired as software engineers, or through data engineering, through SQL, Python, and microservices, REST API, caching, all those concepts, you can those end up being your biggest advantage when you enter into this agentic space, because the ecosystem gives you the opportunity to use these skills to provide additional capabilities to your model. And it always requires, even though there is automation, it always requires human insight. Human insight is the most important thing in these aspects. So what I'm trying to stress here is the opportunity these things are opening up. So the cloud market is exploding with Google, GCP, Azure, AWS, Alibaba Cloud, every other cloud vendor. What they are doing here is they are taking this opportunity to provide infrastructure for the AI space. And with the increasing infrastructure, the compute, storage, and all those capabilities within the cloud, the AI market is also catching up pretty fast. And this is just another slide, what I was talking about, the huge opportunity that is there within the agentic space and the generative AI space. So I want to jump to this slide because I want to emphasize on the skills that are required to kind of make a mark to easily pick up these things within GenAI and agentic. So Python, as you know, is the key skill required for this, alongside Java and SQL, because the common denominator here to pick up these frameworks, like you have a bunch of frameworks in the market: LangGraph, LangChain, Spring AI, through you have a bunch of frameworks that are out there, which you can adopt using Python. And there are certain frameworks like Spring AI that is focused on Java. Then you, for the for training and all, you need a good grip on database concepts, and that would require, so you have something called as rags and vector databases, which pretty much are repositories to store your data. So you require a good amount of SQL knowledge, the idea of database concepts and all, to pick those skills up. So Python and SQL form your baseline, and skill and your conceptual understanding of distributed architecture like caching, then APIs and all that stuff will add to easily getting into this space. Because in the past, the barrier to get around into this space is that you need to learn a lot of math, you need to learn a lot of algorithms, you need to learn a lot of optimization techniques within deep learning and all to get to this area. But where GenAI and agentic are kind of helping people get into this space faster is there is a level of abstraction around the training part, and you have cost-effective trainings and expensive trainings. Like fine-tuning is a very expensive alternative for training a model, but you have other ways you can do, like RAGs and prompt engineering and all, which are more cost-effective, that require an understanding of database concepts and other disciplines to train your models. So if you see the top skills that are required around this area are belonging to NLP, fine-tuning, RAG, agents, and prompt engineering. And all these things are closely tied to the GenAI and the agentic AI space. So that is one thing I want to heavily emphasize. So Python and SQL and distributed engineering concepts alongside NLP, fine-tuning, RAG, agents, and prompt engineering, these form the major chunk of what you need to understand to get into this space. Okay, so we have come to about 30 minutes. So let's give 5 minutes for any questions on the material that we just covered, and then we'll move on to the curriculum and what we are going to cover and how the course is structured. We'll get into the other part once after this 5 minute this thing. So I will leave it to the folks on the call if you have a few questions, so we can give 3 to 5 minutes to try and answer those questions for the material that we covered up until now.
Yeah, hi, Udit, this is Rupesh here.
Yeah. Tell me.
So, yeah, actually, just brief about me. I am around 25 years of experience. IT
Yeah.
field, so worked on different technology, different areas, and currently into banking. So, I'm about to work on AI project. So that's the reason I joined this training. I'm planning to join this training. So here you will be teaching whatever you have covered in first slide. So all those things will be covered. Like, for
So
example, we'll start with machine learning, deep learning, generative AI, and then agentic, or how it will work. What will
so I want to emphasize the fact here is this is not a full-on machine learning deep learning course. This is heavily dependent on, so your generative AI concepts require a machine learning and deep learning background. So the idea is to cover as much as it is needed to get into the generative AI space. Because the main focus of this course is the tools, concepts, frameworks around generative AI and agentic AI. But that being said, there is a need to understand general machine learning and general deep learning. So one example would be understanding what a neural network is. So to understand what a neural network is, you need to understand what is supervised learning or regression. So as much as it is needed, the plan is to cover that much of machine learning, deep learning, before we jump into understanding the generative AI architecture, the techniques, tools, frameworks that form the basis for that. So that's the idea. But this I want to again emphasize on the point that this is not a strictly dedicated machine learning and deep learning course, but rather a more the main focus on this is generative AI and agentic AI.
So that means basics you will cover, but not in depth, and then
Not
we'll
in
move
depth, yes,
further. Okay. But
as much as needed.
it will be helpful to means further. We'll be providing some materials so that
Yes,
later
I will.
yeah.
Absolutely. So we will provide materials and resources where you can read further. So that will be shared as part of the curriculum. So
Thank you.
we have 2 more minutes. Any other questions?
Yeah. Hi, Uday. I'm Virendra.
Hey,
Yeah. So, it is entirely means new to use it in existing roles, or how it will help us for the existing as a data engineer or data scientist. So it will help us in implementing the GenAI and agentic AI in our daily uh, in roles, or entirely new to implement for the new solutions, or how it is the course or
so
this
a
solution.
mix of both actually.
Okay.
That's a great question because so one thing I want to answer this question in two parts. One is what skills are actually needed to kind of get into this space and how the opportunities are in this space. So from a skill standpoint, so any skills around data engineering, software engineering, system design, and that includes Python, SQL, as I mentioned before, Python, SQL, maybe Java as such, having that understanding kind of is very essential because it will help you acclimate with these concepts even faster, especially in the agentic space and the generative AI space. With respect to how these skills can be applied on the job, I can give you an example. So in my own workspace, so initially when the so I with this company I currently work with, I also started off a couple of years ago as a senior engineer within writing microservices and all. Then there was a need to kind of use data to we accumulated a lot of data in the fintech space, but we didn't know what needs to be done with that data. Like, can I create any opportunities there? So one exploration we did was to actually build out use cases exclusively for using generative AI to adapt to this data. And that required a whole length of creating data pipelines to streamline the data as well as actually have the domain knowledge as to what the data means. So all the software engineering principles kind of helped get the data from not making sense to actually making sense. And then came the generative AI piece, which made it easy to start making more sense of this data. So what I'm trying to put into perspective here is having software engineering skills is very important in getting into this space. And this can either because there I've seen opportunities where you are getting into Gen AI and agentic as an engineer, as a prompt engineer. So there are multiple roles in this. So you have prompt engineering roles, you have roles around RAGs and vector databases. Then you have agentic engineers who build out the workflows for using LangChain, LangGraph through AI, then Llama Index, all these frameworks. You are giving additional capabilities to these generative AI models because all these models require training with company data. And whenever the reason I'm saying data so many times is it data engineering and data software engineering and data are not like both are tightly coupled. So whatever your skills you have gained as a data engineer or a software engineer, those are very helpful in getting into this space. Another use case I can tell is I use Amazon Q, Cloud Code, GitHub Copilot, all these products as uh, supportive tools in helping me to code. Then within another product which I've worked on is a chatbot using Amazon's Titan models, which we trained with all the company's workflows and processes. So we don't have to go into Confluence or Jira or any other external place and try to get information about some workflow. All we do is put a prompt in that chatbot, and the chatbot gives us the entire workflow and everything, because behind the scenes, it's a generative AI model that is trained with the company's Confluence data, data in Jira, data in the company databases, and all that stuff. So it knows, it has that intelligence. And there are teams that manage the entire product. And these engineers are coming from our own software engineering pool, data engineering pool, DevOps, all these people. So to answer your question in short, there are roles that are pretty much targeting generative AI and agentic requirements like prompt engineers, RAG engineers, agentic AI engineers. And there are roles where generative AI and agentic knowledge becomes an add-on to your existing data engineering or software engineering portfolio, what you currently have, set of skills you will have. So it
Okay.
works both ways.
Okay. So I think this will help us in if I want to the current organization implement generative AI with the agentic AI solutions. So I think it will help us
Yeah,
in
absolutely.
our domain. Is that correct?
Absolutely. Yes.
With this knowledge in this course. Okay.
Yes.
Yeah. Thanks. Uday.
Yeah. So let's switch to the second part of the section. Let's go through what we will cover as part of this course, and we will leave time for more questions at the end. Okay, so let me switch to this. Can everybody still see my screen?
Yes,
Yes,
sir.
Uday.
Yes. Yes.
Okay, so the baseline, so in order to, so there are, we need an understanding of machine learning. So I'll just write these topics and we'll fill each of these boxes. Then we have to understand deep learning. Then we have to understand the architecture of GenAI. Then there are other concepts around GenAI training. Then we will talk about agents and concepts surrounding that. Then we'll look at a capstone project that tries to cover all these concepts, what you have learned. And throughout, our core stack, what we'll cover, what we'll put into perspective and fill would be Python, SQL, system design. So we'll fill each of these. So with machine learning, we'll understand the nuances around machine learning, such as classification, regression, then reinforcement learning, clustering techniques, then dimensionality reduction. We'll also understand what is, even before that, we need to cover what is supervised learning and unsupervised learning. And one step even above, we have to talk about structured data and unstructured data. So the idea is we will cover these topics, mostly whichever these topics are will get us into this step. We'll cover those in detail, pretty much in detail. So whatever forms the baseline for us to get to deep learning quickly, we'll cover those topics in more detail. The other topics we will cover in necessary detail, but I will make sure that we will provide the necessary reading resources in case you want to explore those even further. Now, with deep learning, so deep learning is a hugely vast subject, but for us to get from here to here, we need to understand a few things. So we'll understand the nuances around what a neural network is. Then we'll understand the optimization, regularization techniques, how these apply to a neural network. Then we will focus on covering the recurrent neural networks and LSTM, long short-term memory. This is another type of neural network. Then we'll understand what is the context of what is the concept of attention. So these are the main topics we'll cover within deep learning, because this will help us get to the next step, which is GenAI, architecture of GenAI. So we'll spend a good deal of time understanding the conceptual things around GenAI. So that includes, let me just move this up a bit. Okay. So within the architecture of GenAI, we will understand what are transformers architecture. We'll look at this in detail, and this will cover encoders, decoders, all those concepts. We'll understand what are embeddings, what are vector databases. Then we'll understand what are foundation models. Then we'll understand the concept of RAG, fine-tuning. So once we have a good baseline of all these concepts, so we'll go through small examples here. So what between these three concepts, what we'll try to do is keep the math at a minimum, but we will definitely provide code samples, executing that code, going through that code, what it is doing, and how everything ties up. Say, if, for instance, if we have to go through an example of what a recurrent neural network is, we'll have an example in PyTorch or TensorFlow, but the example is for the intent of understanding the concept. But the intention of that example is not to teach you PyTorch. So I want to make the distinction there. So we will provide code examples. Additional resources to read further. And we'll have, when we cover the architecture of GenAI, we'll have small mini projects. So we'll use Olama for that. So with Olama, you can run something called as small language models on your Windows or MacBook or a Linux box. And
Uday, sorry to interrupt. If possible,
yeah.
can you increase the font size a bit?
Yeah. So let me do this.
Oh, okay. Now it's good. Very good. Yeah.
Is this readable?
Yes, yes. Thank you.
Okay. So all these, so we'll start looking at using Olama when we hit this third box. So what this will help you do is you can run models in your laptop. Like, it doesn't require any fancy setup, but we'll walk you through that. And you can start practicing these concepts in your own laptop, what are RAGs, vector databases, and all. So at this point, we will also start understanding. So we'll also start exploring the GCP Vertex AI ecosystem as well at this juncture. So once we have a very good baseline around these fundamental concepts, then comes understanding the frameworks. So with GenAI, you have LangChain as the framework, LangChain and LangGraph. But both are these used between Agentic AI and GenAI. So we will cover in detail what LangChain and LangGraph is, keeping in perspective these concepts. So we'll cover more techniques and all. So whatever you see here and what we will cover in the class will be more extensive. I just want to kind of provide a very high level view here. But taking as to understanding what LangChain and LangGraph is, then we'll also see the Hugging Face API. We will cover a couple of vendors like OpenAI API ecosystem, and then how this will kind of help you is, so we will cover foundational models. So when we talk about foundational models, you have different vendors providing different models. Like your ChatGPT is an example of a foundational model. Like, it's run behind the scenes, it's a foundational model that is powering ChatGPT. Similarly, you have vendors like GCP, Amazon, Azure, then OpenAI, Anthropic. All these people have their own models they use for different use cases. Like GitHub Copilot is run using a model called as Claude that is sold by this company called Anthropic. So we will cover all those things here. So how we will cover those is, so whatever concepts we cover here, this entire section will build on top of that, because with Ulama, it will give you a means to understand a generative AI project end to end. But we also need to make sure that we are well versed with the latest and greatest technologies that are available in the market. So that kind of comes after this. So once we are in a good place with respect to the generative AI, then we'll get into the agentic AI ecospace. So we can, sorry, I forgot a very important thing here. We'll also cover prompt engineering in detail. This is one of the most important things within this ecosystem. So with agents, you will take the GenAI one step further, which is to provide it additional capabilities to automate a lot of things. And that we can include, so we can cover through AI, the ecosystem, like this is for creating agents without writing much code. So codeless agents. Then we'll again cover LangGraph. LangGraph is used to build your agents. Then we'll understand what MCP protocol is. And we can also cover other tools as well that we can use to build agents. So we will have smaller projects building around these three ecosystems. One is like we can have a GenAI model, a small language model, on top of which we'll use some generative AI concepts to build it into a project, and we'll give it a capability, say, to query from a database or to send out an email. So we'll have a small project that we can work towards within the agentic AI space. So we'll cover a couple of other tools as well and a couple of other concepts. I'm just giving an overview here, but the forthcoming classes will cover all this in more detail. And the capstone project would be a combination of all what we cover between these three boxes. And we can enhance the project as needed, in the sense that, say, let's take a small example. Say if we have, we'll take a real life example where we can do sentiment analysis for comments that are added to, say, a video or something like that. Then the capstone project can also be like, we can have something like fraud detection within the cybersec space, like a small project that looks at logs, and if it generates an output, and that based on that output you can send out an email or raise an alarm or do something on those lines. So the idea is so we can also cover the agents orchestration. So here we will again touch base on the Google Vertex AI offering. because with the capstone project, we'll try to focus around understanding the project end to end and what are the aspects around the hosting a model, how to host a model. Then once you train, how to version the model. So hosting, versioning, training. So we can cover these within the context of Google Vertex AI. So because we have to be a little bit cognizant here of the cost as well. So we will try to cover as much in depth as possible so that you can go back and explore further and deploying. So this is how this particular training is structured. So from a time perspective, so we are looking anywhere between 45 to 50 hours. So that will get you around two and a half months. Satish, is that correct? Satish Naga, 2.5 months, right? 50 hours, 45, 50 hours.
Yeah, as per our plan now, it will be 50 to 60 hours.
Yeah.
Yeah.
So, okay. So just looking at the time. So where are we at time? Okay, so I will stop here for more questions.
Are we covering anywhere on LLMs or and the optimization? Any example case like how to optimize
Yeah,
LLMs?
so LLMs will come under the foundation models. So the architecture of GenAI will emphasize on LLMs because the we have multiple ways to look at this. So if you look at a foundational model, it could be, we can either talk about a model like Stable Diffusion, which generates videos, or you can look at other models which generate images. But right now, from a usage standpoint and where what markets within the company adoption, rather the enterprise adoption is around the LLMs. So the foundational models, the transformer architecture, these two things will focus around the LLMs. Does that answer your question?
Yeah. And the other question is, these LLMs optimization, will it be going to be on the Python or is it like on the C language? Because I heard that LLMs have been developed in a C or the Python. That's how the people were talks. So I just want a little bit info.
So if you look at an LLM, the underlying LLM is abstracted by a framework like PyTorch or TensorFlow in the real world. So from what I've mostly looked at, all the training and all the optimization training. So fine tuning, prompt engineering, RAGs are ways to train and optimize your foundational model. But the idea here is the cost. I'm just getting into the details a bit, but if you take, for example, RAG and prompt engineering are cheaper techniques to fine tune and optimize a model using external data. But if you use fine tuning techniques, you have to go one level down. So you have to use these regularization optimization techniques that you use on an actual neural network to train to even make your LLM better. But that comes with a cost. And you can do that using Python. I understand C also provides an alternative like that. So you can have machine learning frameworks written in C++, sorry, deep learning frameworks written in C++ or C, because they offer better, like you can directly optimize the GPU to run your neural network. So it makes absolute sense that your LLMs, the training and the framework to train the LLM is written in C or C++. But at least from the broader use case, your foundational models, your LLMs, all the training happens keeping in perspective a Python-based framework like PyTorch or TensorFlow. Majority. But again, I'm talking about the most common use cases, but there are definitely use cases there as well where you have C++ and C-based frameworks that are used to train your models and build your model as such.
Yeah. Uday, I think a
The,
couple of people asked about the basic difference between GenAI and Agentic AI.
yeah,
If possible, just touch that.
yeah. So let's take an example. So if I have a model, so this model is trained with all data from the internet. So hundreds of web pages, documents, and everything. So you train your model, and what that model does is it generates new text. You're not predicting anything. You're generating new data, new information from existing information. So this basic operation, look at generative AI as this basic operation. Now extend the same definition to audio, video, and images as such. The type of data doesn't matter. And within text, you can like generate extensively. Like you can write a paper with this, you can generate new content, like write reviews. When you say new text, you can even write a research paper using this new text, or you can generate an email as such. But all this model is doing is generating something using some training it has on this data. If you look at a microservice, let's take a simple microservice in your software engineering world. This microservice can do a lot of things. It can send emails, call APIs, publish events, talk to a database, and run SQL queries. So that's what makes the microservice architecture, or this could be anything. Like it could be a simple web application, microservice, or a web application. This makes it very powerful. Like your microservice or a simple web app could do all these things. But in this case, it is self-supervised in the sense that the model will become intelligent enough. As soon as you input new data, it will find the patterns on its own and generate the new text or perform some action like this thing. But in the microservice or the web app world, you are writing classes, you are writing code. You have to actually put the if-else conditions, switch case statements to deal with different conditions and to understand what to do next. Like, so for a particular output, you will do this step. For another output, you do this step. You are building all that intelligence here. And whatever data that comes here into this, you have to structure that data from the database. Then you have to create DTOs. You have to parse that data, and it's in an XML file. It should be in XML, JSON, and CSV. So it should follow certain structure. This is all unstructured data. So if you can give all these capabilities, sending emails, calling APIs, all these capabilities to a model, because as an engineer, you have to manually perform this step. You have to manually write logic here. You have to manually tell when to do what. But here, the human intervention to make sense of the data, that entire step is gone. So as the model gets a better training, if as the training continues, it becomes good at understanding the patterns on its own without human intervention. Agentic, so this is where the agentic AI ecosystem comes into the picture. Sorry, not the agentic AI, generative AI. Now, giving this particular piece the capability to do all this, automate all of these things. Instead of worrying about, okay, when to do what, defining these workflows, this is where agentic AI makes the generative AI model more powerful. Giving this capability to this particular model makes it powerful. And how it scores over your regular microservice app is the amount of code required to set this up. Then you have to orchestrate it, you have to deploy it, you have to version it, you have to maintain it, doing all that stuff. That overhead reduces here because you don't have to worry about structuring the data. It's all unstructured data that you feed the model. The model becomes competent enough to understand the patterns on its own, and it becomes automated. Then you are adding additional capabilities by providing tools, workflows, defining these things. It can be even Python methods or Java methods. So this is where your agentic AI piece gives the generative AI model that capability to perform all these tasks. Thereby, the overhead required to maintain version and do all that. So your entire effort goes into making sure that your model is performing well for a certain data. So that's what it comes down to. So that is the line between generative AI and agentic AI. So does that answer the question? Any other follow-up questions around that?
Yeah, I hope. Okay. So any more questions? Yeah, someone is asking.
Yeah.
So can we create our
one
own agents independently after this course?
You
Yes,
should
right?
be able to, yes.
Yeah.
Yes. So the So Olama will give you a good understanding of that ecosystem. So running, like you can host a model on your local machine. Right? It's a small language model, but it will like you can have something like a ChatGPT like model on your running on your local ecosystem without having to worry about a lot of things. So when we go through that, we can like we'll provide more understanding how to build your agents and all. As we go up this ladder, you should be able to create your own agents by the end of this course.
Yeah. So is this slide, can you share so that we can go through it?
Yeah. I'll share all the material, the slides and everything after this class.
Sure, Rupesh will get it. So, okay, I hope.
So I have one last question on that. So basically, even I am means we have some projects that I need to work on. So it's already started. So it's kind of as you said, there are some models which work on Jira and Confluence also. So are they ready-made or we create them?
So it all depends on the hosting infrastructure. Say, I'll tell you the example of my company itself. So my company has access to a Confluence instance where we host all our documentation there.
Right, right.
We also pay for the infrastructure where that Confluence is hosted, and that being AWS. And with that, we also have a chatbot within that's integrated. It is integrated with Confluence itself. So that model is hosted on AWS, but the front end chatbot and everything is through Confluence. What I'm trying to say here is based on where you host, either the infrastructure which you are paying to host your Confluent instance as a model integrated with it, you're paying for that as well as a package. Or if you are hosting Confluence or Jira on your local company's infrastructure, and if you're getting the advantage of using these chatbots and generative AI chatbot on Confluence or Jira, there is in the backend, there is a model that is hosted on the company's infrastructure. Does that answer your question?
Yeah, that's actually overall covers that. So only thing is that, like for example, we are having Jira, we are having Confluence. Confluence we
Yeah.
put the documentation, and then Jira it's a work management tool. So there we are having, like for example, we are having issues, we are having stories. So
Yeah.
finally, at the end of day, if we want to analyze that data using a agentic AI
Yeah.
agents, and then produce some prediction based on that. Like for example, if it is a bug related, so what kind of bugs usually comes into our system, and then what uh, solution maybe we can automatically provide or troubleshoot. So those kind of things, if we want to do, are there existing APIs which we are going to use, or we are going to create our own LLM sort of thing? I'm
So
not sure
the
whether
concept,
it's making sense, but I'm just
it
asking.
does, it does, it does, because this is an actual use case I've seen with the QA team in at my company. So they
Mhm.
want to like you have bugs that are defined on Jira. They want to get some insights on that information.
Right, right, right.
So ideally, you should train. So again, this is not a actual solution, but I'll just provide some perspective how it works. So ideally, you should have that data come either through APIs or you can do a data dump like a CSV file. Then you train your own LLM model. Rather, let's not call it an LLM, the foundational model. provided it could be like you can have GCP, again, same thing. If you are having a cloud vendor, they have their own models. Like for GCP, it's Gemini. For Amazon, it's called Titan. So you have to train your foundational models with that data to make sense.
Got it.
Because
So that means those models are already there. We need to use them and train
yeah,
so that it comes.
these models are trained with general data. That's what I said. See, the internet, whatever data is available on the internet across multiple topics, these models are trained with that data. So if you open ChatGPT and you answer a question, say, let me give you an example. Mm, So this is run behind with a model called Grok. Okay. So if I say, what is the temperature? So it is, we are talking about temperature here. Then if I say, so the behind the scenes model here is trained with internet data. So you see this 25 web pages, all that stuff. It's defined with generic data. So that is what is called a foundational model. But if you want to talk about a specific topic, you have to train with that data. That's where your data related to Jira, all your bugs, issues, epic stories, tasks that comes with that you need to train it with. Because you want to ask questions or handle queries pertaining to that information. So you have to train your model, train that foundational model with that information.
Okay, one last thing I'll ask. So
Yeah.
suppose, for example, when we talk about data, there are privacy issues, especially if you are working in bank. So is there any guardrails which are already there, or are
Yeah,
you
you
covering
can.
that suppose if I don't want to share my data publicly, just want to use it at a specific place, and then using this LLM. So general concern comes is something like if that data is not getting misused by these LLMs. So when it comes to banking, then it becomes more. So are there any guidelines for that also? Like you
So
said, human insights, or how we
yes,
control it
so
actually? That's a
it
question.
depends. That's depending on company policy to company policy.
Okay.
But because if I say if your Aadhaar number, it's not something you put it in public, but your LinkedIn profile is public data. You can share it with the public. You see my point?
Hmm.
So it depends on your company's guidelines, data guidelines. But that being said, there are tools available with your cloud vendors that can help you define those standards. So if I look at the Amazon ecosystem, you have Macy, you have guardrails. These are products which prevent data from not being like this. Macy will hide very confidential data in your query,
Okay.
like
Okay.
in the answer the query gives. And guardrails also does something similar. Like if the answer that comes back is supposed to be, it should not have curse words or something like that, bad words and all. So you
Hmm.
can define all those rules.
Okay.
And you can even when we cover prompt engineering, we'll cover a couple of things called as one-shot prompts and multi-shot prompts and all, which where you can tell the you can prevent a certain way to for the model to not answer.
Okay. Okay.
So, but in hindsight, the thing is, it depends on your company's data guidelines that you have to define these guardrails and everything to make sure your model doesn't give those kinds of outputs that are not that should not expose critical data.
Yeah, just in short, actually, what the concern was that, as you said, we use foundational model. So foundational model, when we use, that means we are providing our data to that foundational model and training it. So is it kind of, when we give that data, is there a concern that data could be used by whoever developed that foundational model, like Google or Azure? It will get.
No, so
Oh, okay.
so these foundational models, like they won't give you, they will give you your own foundational model, but
Oh, okay, okay.
these companies won't use based on the documentation they
Yeah.
provide.
Mhm.
The idea is these companies will not use your data to train their models.
Oh, okay,
It's
okay, got it.
it's privacy this thing. So
Okay, okay, got it.
yeah,
Oh, great, great, Rupesh. You have a lot of questions, which
Yeah.
are useful to everybody.
No,
Yeah,
actually,
yeah.
I'm working on a prototype, and
Right,
these are
right.
the
Got it, got it.
questions
Yeah.
here.
In any training, if the 1%, 2% knows much, little bit more knowledge, the questions will be different. The
Yeah, sure.
questions, same questions, answers will be useful others also.
Yeah,
Yeah,
sure.
great. So
Thank
yeah, to considering time, Uday, so can we conclude, or anybody have any more questions?
Yeah, hey, Uday.
Quickly, we can close in another
Yeah,
5 minutes.
can
Okay.
yeah.
we after this course can we like search the job or
Yes. So the from an opportunity perspective, so I want to emphasize a couple of things because, as I mentioned, post this course, you will have a good idea around and a good expertise around building agents and building generative AI projects end to end, how things are. So it opens up opportunities within as an agentic engineer, prompt engineer, RAG engineer. So all these are up and coming opportunities that are opening up in this space. This also is good to have, like understanding all these concepts is very important because this works in tandem with your data engineering roles. Because if you are a data engineer, there should be an end goal of using that data somewhere. And that end goal is the predictive analytics space and this GenAI space and the agentic AI space. So that's the end goal. So that's the reason why I said all these transfer skills you gain through software engineering, data engineering are very important to get to the next stage, which is this one. And the idea is to keep the barrier to get into this space at a minimum so that everybody can kind of get into this space and understand the ecosystem and get a good job and bump up your pay, bump up your salary as such. So this is the for in the next 5 years, counting this year, this is going to go places, GenAI and agentic. The US, as I showed you, like the amount of investment going in companies adopting these software disciplines is going very fast. It's going very fast. And I'm seeing here, I and Naga, we do a lot of research around the job market, and we are seeing a lot of opportunities opening up. And this space is still in its very early stage with respect to frameworks and all. And it's growing very fast. So it is a very good time to get into and take advantage.
Yeah. Thank you, Uday. So I do some research also. I did and verified in a JDs, also job JDs, especially in Nauk and other areas. I could see many openings are started.
Yeah. So in conclusion, so
Yeah,
the
excuse
forthcoming,
me, Uday. Yeah, Joshua this side. Just small question from my side.
yeah.
So regarding like yeah, you spoken like with many people, so I hope they are well experienced and having some good experience in IT. So coming to us, we don't have any prior experience in IT or else nothing. So let us consider as freshers. So how the course would help us to get into this? So we're gonna learn from
So
basics to high end so that we can make
see,
some career out of this.
so you have to understand the prereqs for this course is to have an understanding around Python, SQL, and system design.
Okay.
So having that understanding would definitely help get into this space faster and get a job as well. But if you're saying like if you want to get some understanding around Python, SQL, we can definitely share material around that so that you can upskill yourself quickly so that uh, you will be able to follow these lectures as such. So
Yes,
Satish,
yes, exactly.
Yeah.
So what
So
I'm
hello.
saying is like we don't have a like experience with Python or SQL.
yeah,
We
yeah, I
haven't
can
gone through
answer.
them.
Maybe so they can I take control for just 2 minutes? Is
Yeah,
there
yeah, please
anything
go
from
ahead.
your
Yes.
end, or is it okay?
No, I'm done.
Yeah, done, right? Yeah. Thank you very much, Uday.
Yeah,
Just to give
I'm
me a
stopping the
minute.
sharing. Please go ahead. Yeah.
Yeah. So basically, guys, so many people has some question like, so Varahi introducing or presenting this course. Just I have stopped recording for this. Let me stop.